Hello. This lesson, we're going to talk about surface area. So in the last lesson, we talked about how to classify and identify these three-dimensional shapes. And we also talked about the net drawings of them. We're going to use both of those in this lesson as we calculate the surface area of 3D shapes. So, for instance, if we have a rectangular prism, I'm so sorry, I could not get to the pause button fast enough. I actually do want this to be a little bigger so I can write some numbers in there. So be thinking in your mind, what is a rectangular prism exactly? Well, that's like a cereal box or a shoe box. It's not a perfect square, so it's not a cube. It's got a rectangular front and back or a rectangular top and bottom. So it's not a cube. A cube is a square prism. We're not talking about a cube here. We're talking about a rectangular prism, just like so. Now let me put in some back pieces. Obviously, you wouldn't see this because it's the back side of the shape, hence the reason it's dotted. 32 lessons in, and I'm getting pretty good at this drawing on this whiteboard. Okay, here's our rectangular prism. And we want to find the surface area. So the surface area is that, simply that. It is the area of the surface. We're not talking about anything inside. It's the area of all the sides added together. Total area of all sides. That's your surface area. How many surfaces are on the outside of a cereal box? To the top and the bottom, the left and the right, and the front and the back. So you have 6 sides. So you're going to add up 6 areas. Let's put some measurements with this cereal box. So let's say this is 2 and 12 and maybe this is 10. So we need to find the area of all of the sides. Well, this could be side A, side B. Actually, let's do this. This is the bottom of the cereal box. This is the top. This is the left. And this over here would be the right. And then we have the front and the back. Okay. So I'm not going to label the front and the back because I think we can see them. But let's figure out the area of all of these sides. So the left side, what shape is that? That is a rectangle. It's a quadrilateral, also a parallelogram, all angles 90 degrees. Remember all those characteristics of rectangles. What makes it a rectangle? The two pairs of opposite sides are the same length, they're parallel, adjacent sides are perpendicular, all of those things. We need to remember those as we go through these shapes. So the left side area equals base times height. 12 times 2, which equals 24. And it's square units. Let's just say this is all inches, so we'll say 24 inches squared. All these units are in inches up here. Okay? The right side, is it any different? Isn't it the same? Same. 24 square inches. Okay? The top of the cereal box area equals base times height. 10 times 2, which equals 20 square inches. The bottom, same thing. The area equals 10 times 2, which is 20 square inches. And the front and the back. So the front of the cereal box is also a rectangle. The area equals 12 times 10, which equals 120 square inches. The back, same, 120 square inches. For your total surface area, you're going to total up all of the sides. Total area of all the sides. So it's the left plus the right plus the top plus the bottom plus the front plus the back. Add all those numbers up and you have the surface area of a rectangular prism. So 24 plus 24 plus 20 plus 20 plus 120 plus 120. The total of all those is your surface area. Go over to your TI-30 Access Multiview calculator, add that up real quick. And I believe we're going to get 324. 328. (328) inches squared. Easy peasy on a rectangle. Just add up all your sides. Well, other shapes are a little more complex. For instance, how about a cylinder? So the surface area of a cylinder is a lot like trying to find the volume of something, but there is a formula. It's 2 pi times r squared plus 2 pi times radius times the height. 2 pi r squared plus 2 pi r h. Really no way to remember that one. I don't have a snappy little riddle or anything for you on that one. It's the area times the circumference times the height is all I can come up with. If we put some actual measurements with this, Let's say the radius is 3 and the height is 10. Let's just do a 12. No, we're doing a 10. And let's put this in centimeters. 10 centimeters tall, and your radius is 3 millimeters. Review that unit conversion one time. We're almost finished with geometry, and I don't want you to forget it. All right, so let's put everything in the formula. So 2 pi times the radius squared. So the surface area, usually denoted with a capital SA, equals 2 pi radius squared. What's our radius? 3 millimeters, so 9 plus, because 3 times 3 is 9, 2 pi radius, just 3, times the height. Well, what's the height? We've got to have the same unit. So we have to take this 10 centimeters, convert it to millimeters. Remember, centi means 100, so 1 meter equals 100 centimeters. And milli means 1,000, so 1 meter equals 1,000 millimeters. I think it's because a millipede has 1,000 legs. Actually, they may have just named it a millipede because it has so many. Because I don't think a centipede has 100, but that would be an interesting science experiment to see if that's accurate with the prefixes. Does a centipede have 100 legs? And does a millipede really have 1,000 legs? Or did we just name it that because a centipede doesn't have nearly as many legs as the millipede? I don't know. You let me know. Therefore, there's one difference between a centimeter and a millimeter. 1 0, 1 place, 1 factor, so that's 10. 1 centimeter equals 10 millimeters. We're going to go from millimeters to centimeters. We're going to go from here. Excuse me. No, we're not. We're going from centimeters to millimeters. We have to change our height to millimeters. So the number's going from a 1 to a 10, getting bigger. So we have to multiply our 10 centimeters times 10. So that's 100. So 10 centimeters times 10, well, my goodness, equals 100 millimeters. So the height of this is 100 millimeters. Okay, so in our box, we will have 100. Put all that in your calculator. 2 pi times 9 plus 2 pi times 3 times 100. Now you could actually put in 18 pi plus 600 pi, and it will spit out to you 618 pi. 18 pi plus 600 pi is just 618 pi. However, let's put it in the calculator. Move this over. If I just messed up your view, it'll be back soon. Oh shoot, let's go put this back. I can't see my thing. You can't see my calculator at the same time as I'm using it. You could if I could remember what I was keying in long enough. So we're doing 2 parenthesis pi. I promise you I'll show you the calculator. Parenthesis 9 plus 2 parenthesis pi parenthesis 3 parenthesis 100 parenthesis. I did that exactly like we had it. So I'll let you see exactly what I keyed in. There's my keystroke. Put it exactly like it was on the screen. And I even had the 3 and then the times 100, which you can't see it, but you can see my keystrokes here. 618 pi. Now let's convert it to a decimal. That's about 1941.50. 1941.50. The surface area of this equals 1941.50 millimeters. Well, what is that in centimeters? Remember when we did this? We converted square units. So if a centimeter is 10 millimeters, we had area we would multiply twice. But we're going from millimeters to centimeters, so you have to divide by 10 two times because it's a square. If it was volume, cubic units, which you'll see in the next lesson, we would divide by 10 three times. But since it's a square unit, right here, square, and we have this squared, and we have to divide twice. So that means our decimal is going to scoot to the left. It's going to get smaller. 1, 2. So in centimeters, our area is 19.415 square centimeters. And there you go. You could convert that to inches. There's 2.54 centimeters in 1 inch. So if you converted that to inches, it would just be 19.415 times 2.54. So it'd be about 40 square inches. It's not a very big can. That's where I was headed with that. This unit, millimeter, when it's 1941 millimeters, it makes you think that's a big can, but a millimeter is a teeny tiny unit. So 19.4 times 2.54, that's about 60 square inches, maybe? Almost 3. It's between 50 and 60 square inches on the outside of this can. So that's not a lot. All right. Now let's look at another shape. What about a cone? So the the surface area of a cone has a different formula. A cone can also be called a circular something. Is it a prism or a pyramid? Got a point on the top. You can hang a star on it. That would be pyramid. If it's pointed at the top like the Egyptian pyramids, then it's a pyramid. So a cone is also called a circular pyramid, just to be technically correct. And the surface area for a cone is pi times r times s, like Sam, plus pi times r squared. What is s? S we talked about just very briefly with triangles, and again when we looked at net figures. I mistakenly called the height of a pyramid something, and I told you that's really not the height. I misspoke. It's the slant height. So the slant height is this measurement here. Here's our cone. See how we can hang a star right on the top on the point. You can't sit there. That makes it a pyramid. The slant height is this length, this distance, this measurement here, up the side. That is your S, or your slant height. And your height is just like when we had triangles. You have to take a perpendicular line from the top middle straight down to the base middle. So if you had a fishing line with a rock tied to it and you dropped it in there, it would be the length of that fishing line would be your height. I wonder what you're going to have to do to find height and slant height when you're trying to find the surface area of cone. Because look here, when you combine these, what do you have? You have one of those handy dandy right triangles, and the slant height is simply the hypotenuse. So you're probably going to have to use the Pythagorean theorem to find the slant height, which you can do. C squared equals A squared plus B squared. And the H is just one of your legs of your right triangle. No big deal. So you can always find the slant height if it's not given to you. Sometimes they'll give it to you. Now, this short leg of your right triangle, what is it? This bottom piece, this one, there's a name for that on a circle. Oh, I hope you see it. That's your radius. So you can't forget your Pythagorean theorem and your right triangles just because we're dealing with cones, because now you're going to use all of that you learned with right triangles and Pythagorean theorem to figure out the radius, the height, or the slant height of a cone, so you can figure out how much paint it's going to take to paint the outside of it, or also known as the surface area. Okay, so write that formula down for your cone. And another area that we have, surface area, would be that of a ball. So a ball is also called a sphere, and that's a two-dimensional one. There is a way to make this look three-dimensional. So, there we go. And here, kind of colored that in. Anyway, there you go. There's a sphere. This is a ball. Okay. The area of a sphere. Surface area, excuse me, not the area. The area of a sphere is different. The surface area, this is only what's on the outside layer, the outside surface. So if we're talking about Earth, we're talking about the water and the land. That's how much water, not gallons of water, but how much of the crust of the Earth is covered with water and land. So just the surface is 4 times pi times radius squared. Well, the radius is from the center out. So there's about 1,000,000 kajillion different radii on this. I'll just pencil one in. It's from the center to the edge. There's your radius. That's all you need to know. If you knew how thick the Earth was, you could figure out how much was covered with land and water on the outside. Figure out the surface area of the Earth. Figure out how much seed you need to purchase to cover the whole Earth in grass if you knew the surface area. That's a good project. Then we have one of those pyramids, specifically a rectangular pyramid. So a rectangular pyramid, we kind of dealt with one when we had nets. And the surface area of a rectangular pyramid is B plus L. Now, anytime you see a capital B, that means the area of the base. And this L means the sum of the areas of the lateral triangular faces. Whew, lateral is side. We talked about that when we looked at an equilateral triangle, the side of a triangle. And if you look at a pyramid, it makes more sense than just looking at this horrendous formula. So let's look at, I don't like that either. Do a little different. There's my base of this pyramid. Coming to the top. In the front. Now, if you look at that pyramid, what is it? It's made up of 4 triangles. The 4 sides are all triangles, and they're the same triangle. And the base, which is just a rectangle. Well, the L, the sum of the areas of all the lateral triangle faces. So you just need to figure out the area of one of the triangular faces, multiply it times 4 if it's a square. If the base is a rectangle, those will be different areas because they'll be different size triangles. Add up all 4 triangles. What's the area of a triangle? One half the base times the height. Well, the height of that triangle, is the height of that triangle not this line right here, which is also this line right here, or this line right here? Those are all slant height. The height of that triangle looks like that right there. And then the area of the base is just base times height. So if you had some measurements on the base, maybe if it was 18 and 10, and maybe let's find some measurements for the rest of our if we're given that the height of the triangle, which is this one right here, that height in the middle, if that height is, excuse me, 12, not that triangle face height, but let me pull this triangle out and look at it. So right there in the middle is that shape. What is it? Oh, it's a right triangle. So there are actually 4 of those. inside there. There's one on the front here as well. And if I were to show you where this was on the triangle, this slant height is right here. And then if we go back to the center, that leg of that triangle is right there. And then if this leg would come right through there. So I could just take that piece out of the middle, and now I can figure out that slant height. I have to have that green arrow, or that green colored one, that slant height of this pyramid. I've got to have the slant height because it's also the height of my triangular face. This is this. Take this pink side, the one that we're trying to find the area of. There's 4 of these. Okay. That right there is exactly that lateral triangular space that you see in the picture. This is that side edge. But the height of it is the exact same. The height of this flat two-dimensional triangle is the same as the slant height of our pyramid because it's leaning up against the side of the pyramid. So when you have some of those measurements, you can figure that out. Let's work on this one. So if the length is 18 and the width is 10, so we have a 10 measurement down here. Well, that also tells us the base of this is a 10. And the height of the pyramid itself is 12. So here's 12. This dotted line right down the middle, the fishing line with the rock on it, is 12. That's inside the triangle. That is not the slant height. It's that right there. Well, what's the radius of this? The blue line, what is it? What's the dimensions right here? What is that? Half of 18, because it comes right into the middle. So that is 9. Now the pink line, I'll put it with a heart. What is that measurement right here? That's half of 10. So that's 5. Now you've got 2 right triangles that you can find your slant height of. The slant height is going to be the area used as the height in your area of your lateral facing triangle. So to find these S's, now obviously the front and the back side are the same, and the left and the right side are the same because the bottom is a rectangle. So we just need to find 2 of these. Let's do c squared equals a squared plus b squared to find our first slant height. So that's the hypotenuse. So s squared equals 12 squared plus 9 squared. And you have to end up taking the square roots. That's 144 plus 81. So square root of 144 plus 81 is 15. So that slant height is 15. That measurement right there is 15. So this measurement is 15. Okay. Now we could find the area of that triangle. It's 1/2 the base times the height. 1/2 times 10 times 15 is 75. Okay. Now the opposite side triangle is the exact same. So this triangle over here, exact same measurement. Right there. Those two are the same. 75 plus 75. So far, we've got 75 plus 75. Now we got to find the area of the front and the back triangle. Same thing. So we're going to find the slant height over here. So s squared equals 5 squared plus 12 squared. It's just this triangle in the front with the green hypotenuse now. So in our calculator, it's 25 plus 144, and we're going to end up taking the square root of that. That's 13. So this height is 13. Well, that's still a triangle. It's just got a different height on it. So instead of using a 15 now, we're going to take this 13 and put it here. Same formula, 1/2 times the base times the height. So instead of 15, we have 13. 1/2 times 10 times 13 is 65. So the front and back triangle has an area of 65. And now we just need to know the area of the base. Well, that's base times height, which is 180. You add all those up, you'll get the surface area of this rectangular pyramid. So it's a little easier, I think, to look at that and figure out each side of it rather than trying to remember that big formula. Surface area is just that. It's the area of all of the surfaces. Almost done here, I promise. I know you're getting tired. What if you had a cube? And you took that cube and you took the net figure of it. There's really no formula I can give you for the area of a cube. But if we cut that cube open and made a net out of it, you can see if we folded this back up, this is the top, right? This is the back. This is your front. Here's the left. Fold it all back up. And you'd have a little cube. We folded that whole thing back up. It would kind of look like this. Put it all back together. If we just look at the net of that for just a minute, those are the same shape. Excuse me. What if we're given some measurements and we say this is 5, this is 5, this is 5, and this is 5? Well, now you can figure out each little cube is 25. So you could kind of do this any of the surface area you could do using your net figure, which is what I was doing in that rectangular pyramid. I was just looking at the net of it. So on this one, every one of those is 25. Well, how many do we have? We've got 1, 2, 3, 4, 5, 6. 6 quarters. 6 times 25. Because it's a base times height on each little square. Each little square is 25. 25 times 6. 6 quarters is $1.50. So that is 150 on the surface area. You can do that on any shape. So looking back at that rectangular pyramid, if we had taken the net figure of it, let's see if I can just get my picture back. If we take the net figure of this, let's cut that open. So we have this green base, and attached to each base is a triangle. Take our scissors and cut that open and just look at the net. Isn't that a square and 4 triangles? And this 12 right here, it really doesn't mean anything at this point. It was inside of our pyramid, so it doesn't mean a lot to us when we look at the net. But the 15 is important. That was the height of every triangle. Every one of those red lines is 15. Now, I accidentally deleted my measurement here. That was 10. So that means this side is 10. This side was 18. 18 and 10. Just going to label that. And then 15 on every single one of these heights. So now look, you have 4 triangles. You can easily calculate the area of the 4 triangles and then the square on the bottom. So much easier on some of these complex figures to use your net and then use those formulas for areas of a 2-dimensional flat object. Because a triangle is just 1/2 the base times the height. And then that rectangular base is base times height, or length times width, 10 times 18. Easy peasy. And you just have 1, 2, 3, 4, 5 areas, add them all together, and you get the surface area. You'll get the exact same answer. And it's a lot easier. All right, so remember, step number 1, handwritten notes uploaded. Show all your work. You're going to have all these formulas written out, the algebra that's done with them, all of that. Any of these that give you trouble, you've got to get to homework help. This is a complex lesson. It's a complex concept. It takes practice, and you may need some more instruction. And bring your multiple choice answers from the worksheet to the Google form. Okay, I'll see you in the next lesson.